Hey guys, it's Mr. Wolfe, and I'm going to be going over analyzing data in this video, so you could follow along by taking notes on what I'm writing up on the board on this section. To follow up of what we were doing yesterday, we have our graph that we built from yesterday on our reaction time lab. I put my own data from my own experiment in. And when we look at this table, luckily it's a fairly simple table. You could probably get an idea of if distractions had an effect on reaction time. However, it could still be helpful to make a graph. But I will say is that as we go further along in the year, we're going to be dealing with more complex data sets where there's no way that we could just figure everything out by looking at that data table. What we want to do is we want to take that data and make it into something meaningful, and that's all what analyzing data is. So let's first of all define analyzing data. So on that title, let's just kind of write that analyzing means to discover or reveal something. So when we analyze data, we're just trying to do something where we could take that data and usually put it in some visual way that we could pick up on patterns. All right? It's not always a graph, but especially in the beginning of the year, when we analyze data, we're putting it into a graph form. So the first thing that we need to do when it comes to making a graph is that there's going to be essential components. So we're going to write that on this side of the graph. So I'm going to write essential components, constructing a graph. And that first essential component is choosing the correct graph to make. Choosing the correct type of graph. In this class, the ones that we're going to be focusing on are a line graph and a bar graph. So that's more towards the top of your guys' sheet. All right, so when do we make a line graph or a bar graph? Well, we're going to make a line graph when our data is continuous. And specifically, our independent variable data is continuous. So what do I mean by continuous? Let's give a couple examples. The most common one is going to be time. Because I could measure time from, let's say, 0 seconds to 1 second to 2 seconds and so on and so forth. And let's say that I took measurements at each second. However, I know that there is something that exists between 0 and 1 second, right? There's like a half a second in between here, 3/4 of a second, 1.5 seconds. So even though we didn't take data there, we know that that is continuous, that time is continuous, and so we would make a line graph with time being our independent variable. All right? Another example is going to be something called pH. You may have dealt with this before. It's a measurement of how acidic something is. And again, pH could go from 1, 2, 3, and actually all the way up to 14. But even though we have like these solid numbers, there is a pH in between 1 and 2 as well. All right? So that's when we would use a line graph. For a bar graph, that's when we're going to be working with data for our independent variable. So the independent variable is data is categories. So what do I mean by that? Let's look at a couple examples. So some examples of categories could be a month. April, May, January. It could be sex. So for instance, male or female. It could be maybe your year in school. For instance, freshman, sophomore, etc. And the reason why these are categorical and how they're different from continuous data is freshman and sophomore, there's like no in between here. I can't be like a freshmore, right? I'm either a freshman, I'm a sophomore. These are distinct categories, and when that's the case, we're going to make a bar graph. So if I look back at the data that I collected, I'm going to look at my independent variable on my table. Center this a little bit more. Okay. We're going to look at my data table, and my independent variable is the environment, and I have with distractions and without distractions. There's really like no in between there. Looks like I have two distinct categories, so I'm going to be making a bar graph here. All right. So I've done my first essential component, which is choosing the correct type of graph. The next one is going to be labeling my axes correctly. All right. And we're going to have the independent variable be on the x-axis. We're going to have the dependent variable be on the y-axis. The reason why we do this, it's not like a solid rule, but almost always in this class, this is what it's going to be. It makes telling the story of the data a whole lot easier. So like as something's happening to the x-axis, our independent variable, what's happening to the dependent variable? All right, so let's actually set up our graph for this specific situation. My independent variable, I want to have a title for it. It's going to be the environment. That's like the title of my table right here. And my two categories are with distractions and without distractions. Right. Then on my y-axis, my dependent variable is reaction time. Which we are measuring in seconds. And you want to make sure that you have units. So the next thing I'm going to put here is for labeling axes correctly is units. Make sure you remember them. Okay. The next thing we're going to do for our essential components is going to be the scale. So kind of setting up the numbering here. And how we do that is we're going to look at our data. And I want to look at the smallest number and the largest number. In this case, I really just have two numbers. In terms of what I'm going to graph, I'm not going to worry about the individual trials. Remember, this was just to get a more accurate representation of what that reaction time would be for with distractions and without distractions. So I'm just going to graph the average. I want to get the big picture here. And it looks like my lowest number is 0.3, my highest number is 0.56. In general, this is kind of like in the range between 0 seconds and 1 second. So I'm going to make this 0, and I'm going to make this 1 second. And I know that my data is going to be able to fit within this graph. Not only that, but it's going to be able to fit pretty well, right? If I put 10 seconds up here, my bars would be really, really small, and I really couldn't get a whole lot of meaning out of it. All right. So then, luckily, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So for 1, 2, 3, 4, 5, I can make this 5 right here. By the way, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. All right. All right. When you do the scale, it's really important that you just look at your lowest and highest number and make the scale before you start plotting stuff. The reason being is that sometimes you get data where you might get numbers like 0.1, 0.2, 0.3, and then it might jump to like recording something at 0.8, and then you would put 0.8 there, and that's going to mess up the whole scale of the graph. So set up the scale and then plot. So for essential components, scale. All right, the next thing is going to just be plotting the data accurately. So in this case, with distractions, it was about 0.56 seconds. So I would say that that's right about here. I'll make this bar fairly big. And then without distractions, reaction time was 0.3. All right. So it looks like I'm fairly done, but a very, very important thing that I need to have for my essential components is you always need a title. And the title is always going to have this framework, which is the effect of your independent variable on the dependent variable for your title. So in this case, my title is going to be the effect of reaction time, the effect of distractions on reaction time. All right. And here's my finished graph. So again, going back to the purpose of analyzing data, it's to discover or reveal something. And yes, for our data, you could look at the table, but this is a nice visual way where you look at the title of the graph, it looks like they're trying to see the effect of distractions on reaction time, and right away, you could see the pattern in terms of if it has an effect or not. Okay, for the interpreting data thing, that's what we've been doing all school year thus far, where we look at the graph and we just describe the evidence, having both patterns and specifics. Don't worry about doing that right now. And you guys can always re-reference this video when you're doing your homework or when you're doing any of the other practice that we do in class or studying for any other assessment. Thanks, guys.